Welcome, geometry students, to the homework up video, page 137, numbers 11 through 14, 17 through 24, and 30 and 31. Let's go ahead and get started with the homework right away. Numbers 11 through 14, the directions say, find the measure of angles 1 and 2 and explain your reasoning. So, when it says to explain your reasoning, you don't have to give great details, just a little bit of detail. We're looking to find the measure of angles 1 and 2. Well, first of all, I would write angle 1 equals 120 degrees. And I would simply put corresponding angles, which is sufficient. Of course, the two lines have to be parallel, and they are. And I would write angle 2 equals 120 degrees. And my reason would be vertical angles, and that's sufficient. This angle and this angle are corresponding angles, and this angle and this angle are vertical angles. Okay? All right, number 12. Let's see here. Well, first of all, I would state that the measure of angle 1 equals 110, and I would say supplementary, no, I would not. I would say linear pair is what? Supplementary. And obviously this angle here is a straight line. Here's a line coming off of it, so this angle here and this angle here are linear pair, and linear pairs are always supplementary. Now, what would I say for number 1 or number 2? Well, remember, I would say the measure of angle 2 equals 110 degrees, and the reason would be alternate exterior angles. If it helps you to turn this a little bit, feel free to do that. That's totally fine, so that your parallel lines are going left to right. There we go. You can see how this angle here and this angle here are alternate exterior angles, so they're congruent. Okay. Number 13. Let's go ahead and grab. I'm going to start doing this a little more often. Let's grab this and let's turn it so our parallel lines are going left to right. And here we go. Well, first of all, we should be able to see that this angle here and this angle here are alternate interior angles. So I would start off by saying the measure of angle 1 equals 80, and the reason would be alternate exterior angles. Okay? Now, next, I would say the measure of angle 2 equals 100 degrees, and I would say because linear pairs are supplementary, and it's obvious this angle here and this angle here are linear pairs. You have a straight line here with one line coming off of it, and so we have a linear pair. Okay, and they're always supplementary. All right, number 14. Let's take a look at our parallel lines here. For me, I like to turn these so the parallel lines are running left to right. It's just easier for me. If that does not help you, then you don't have to do that if you don't want to. All right, let's see what we have here. Well, right away I can see that this angle here, 110 degrees, and this angle here are what we call consecutive interior angles. And consecutive interior angles are always supplementary. So, if this angle here is 110 degrees, then this angle here has to be 70, because 110 plus 70 is 180. So I would write the measure of angle 1 equals 70, and my reason would be consecutive interior angles. Then I would put the measure of angle 2 equals 70, because alternate interior angles are always what? Congruent. And so this angle here and this angle here are alternate interior angles. Okay? All right. Moving on to number 17, I believe. And number 17, the directions say to use the given information to find the measure of all the angles that are labeled. So we really got our work cut out for us, and this is not going to be easy. Okay, so here we go. I'm going to cross things off and write things in here. We know that PQ is parallel to RS, so I'm going to very quickly put that on here. PQ is parallel to RS, so putting that on there helps me a little bit. And then LM is perpendicular to NO. They've already got that marked for us right here with the right angle. Okay. And then they tell us the measure of angle 1 is 48 degrees. So I'm going to go ahead and cross off 1, and I'm going to put 48 degrees right here. Now, right away we should see we have a linear pair, And students, I'm not going to really go in order like angle 1, then angle 2, then angle 3, and all of that. I'm just going to look up here and see what makes sense. I mean, if this angle here is 48 degrees, I can see right away I've got a linear pair here, a straight line and a line coming off of it. So angle 2 has to be supplementary, and so the measure of angle 2 is going to be 132. So this is 132 degrees. And I know that because 132 plus 48 is 180. Now, this angle here and this angle here, angles 2 and 3 are vertical angles, so I know this angle right here also has to be 132 degrees. So the measure of angle 3 equals 132. And then same thing with the measure of angle 4. We have vertical angles here, so 48 degrees for this angle right here. So the measure of angle 4 equals 48 degrees. Now, here's where it gets really difficult to see, and I'm going to try to do some stuff here that might help a little bit. Let's get rid of this. We don't need this anymore. And let's see if we can't slide this stuff maybe somehow off to the side. That's not going to work. Okay, here's what we're going to try to do. I want to lock all of this stuff together here so I can turn around. Okay, I think that did it. Now students, watch this carefully. I like my parallel lines to run left to right, okay? So I'm going to turn this a little bit. It's just going to help me see things a little better, okay? Just for a little bit. I have no idea what I just did there, but hopefully we'll figure it out. There we go. Okay, now I've got parallel lines right here, okay? See this? Here's parallel lines cut by a transversal, okay? So with that in mind, that means 48 degrees here and angle 5 are alternate interior angles, okay? We go from parallel line to transversal, transversal to parallel line, so angle 5 right here is 148 degrees. If I can squeeze that in there. So the measure of angle 5 is 48 degrees. I'm not sure why I put 148, but it would be 48 degrees. Not sure why I do a lot of things that I do, but nonetheless 48 degrees. I'm not sure why I put that. 48 degrees. Okay, now let's see what else we can do here. Okay, how about this, students? See how this is 90 right here? Well, if that's 90, then I know for sure this whole angle here, angle 6, plus this 48 degrees, this whole angle here has to be 90. So if this much here, I'm going to circle it for you in green. If this angle here is 48 degrees, which it is, then angle 6 is going to be 42 degrees, okay? Because 42 plus 48 is 90, okay? So now I know the measure of angle 6 is 42 degrees, okay? All right, let's see what else we can learn here. All right, let's see. Well, we have, students, look carefully, we have parallel lines. Here's a parallel line, and here's a parallel line cut by this transversal right here. It's not easy to see, but there it is, okay? Now, let's see what we have here. Okay, I'm back. I had to pause the video for a second so I wouldn't waste your time while I look this over. Okay, I think I've got this figured out here, students. Let me get rid of the drawings I did. Let's use a different color. If you'll watch this carefully, I think you'll understand this. Okay, students? Hold on one second. Get this back up here. Okay, now watch this. This line here, now watch this carefully, and this line here are parallel, okay? And here's a transversal cutting it. Now, this angle up here is 42 degrees, okay? Well, if you'll look, angle 10 is an alternate exterior angle. First of all, here's your parallel lines. Here's the transversal. This angle up here is above the parallel line. Angle 10 is below the parallel line, so they're exterior angles. And this angle right here is to the left of the transversal, and angle 10 is to the right, so they're alternate. So they're alternate interior angles. So with that in mind, let me go get my black pen back up. This angle right here, angle 10, is 42 degrees. And now we're home free. The rest of it's really easy. You're like, really, Mr. Earhart? Yeah. First of all, vertical angles. This angle here and angle 7 are vertical angles. So if angle 10 is 42 degrees, then angle 7 is 42 degrees. So the measure of angle 7 is 42 degrees. And then look, we have a linear pair. Here's a straight line with a line coming off of it. And so angle 8 and this angle here are supplementary. So if this is 42, then this has to be 138 degrees. So that was angle 8. The measure of angle 8 is 138. And then vertical angles. And we have two lines that are intersecting here. And so this angle here and this angle here are vertical angles. Vertical angles are congruent. So the measure of angle 9 equals 138 degrees. Pretty tough problem, okay? But definitely a good problem for you to work on, all right? Now, I've told you guys before, I'm really a huge fan of turning my parallel lines so they're running left to right. So I'm going to do that. So there's my parallel lines running left to right, okay? That's just easier for me. If you don't like that, you don't have to do that, okay? And let's see what we can do here, okay? Which theorem or postulate implies that 6 is congruent to 13? And of course, you're going to assume in a rough, and I'm saying this is a rough. Let's see the vertical studs that are perpendicular to the floor. They're going to be parallel. So here's let's see. What theorem would imply that angle 6 is congruent to angle 13? Let me change colors here real quick. This angle, well look, you've got a line here and a line here. Those are called vertical angles. So the answer to 18 would be the vertical angles congruent. You don't have to tell me the name or the number. Just kind of list out the reasons. Definitely sufficient. Okay, which theorem or postulate implies that 6 is congruent to 15? Well, students, look. Here's a line. Here's a line. They're parallel, cut by a transversal. So this angle here and this angle here, are they not alternate interior angles? So 19 would be the reason is the alternate interior angles theorem. All right, number 20. They're asking us on number 20. This thing's frozen up here. Hold on one second. Okay, students, I'm back. Sorry about that. The program crashed there for a second. So here we go. I had to kind of rewrite everything, but number 20 says, which theorem or postulate implies that 6 is congruent to 4? Well, look, students, again, let's draw our parallel lines. Here we go. And here we go. And then here's your transversal. So here's angle 4. Here's angle 6. They look like corresponding angles to me. So the reason you can state that is corresponding angles are congruent. Okay, moving on now to number 21. And let's see what we have here. 6 is congruent to 11. So 6 and 11. Okay, no big deal. Let's see what we got here. Here's line. There's your parallel lines. Here's your transversal. So we're dealing with this angle here and this angle here. Well, it looks like to me we would call that alternate exterior angles are congruent. Okay, moving on. Number 23. All right. Now, students, this one here shouldn't be too difficult. Let me go ahead and grab this and change it real quick. There we go. Okay. Now here in this problem, they want us to fill in the left side or the right side depending on what they ask for. Okay, so looking at number 1 here, we know the reason they've written something over here in number 1 is that it's given. So if it says given over here, more than likely they've written the given over here. And if you'll look, the given is line 1's parallel to line 2. So that's what should be written here. Let's see if it is. Hopefully it will be. Yep, line 1 is parallel to line 2. Okay, now number 2, angle 1 is congruent to angle 3. Now look at this. How could they state that? We know we have parallel lines. We know we have a transversal. How could we state that angle 1 is congruent to angle 3? Well, they look like corresponding angles to me, so I'm going to assume the reason is we have corresponding angles. Yep, corresponding angles are congruent when you have two parallel lines. Now, look at number 4. 2 plus 3 equals 180. See that? Look at number 4. 2 plus 3 equals 180. Now, how can we state that 2 plus 3 equals 180? Well, they're a linear pair. And am I on the wrong one here, students? Sorry. Okay, we're on number 3. Sorry about that. Okay. So back up here. Number 2 says, sorry, students. Number 2 says angle 1 is congruent to angle 3. And then step 3 says 1's equal to 3. Well, remember, you can do that by definition of congruent angles. The definition of congruent angles is if two angles are congruent, then they have the same measure. Or if two angles have the same measure, they're congruent. So, definition of congruent angles. All right. Now, number 4. How can they say 2 plus 3 equals 180? Well, here's angle 2. Here's angle 3. Aren't they a linear pair? Sure. So the reason would be linear pairs are supplementary. Or they call it the linear pair postulate. That's fine. But if you read that postulate, it says linear pairs are supplementary. And now we're down to the last step, step 5, the substitution property of equality. Well, if it's the last step, then we know it has to be this. Your last step in a proof on the left side, just like 99% of the times your first step on the left side is your given, well, 99.9% of the times your last step over here is going to be your proof. And so what we have written over here is the measure of angle 1 plus the measure of angle 2 equals 180. And what substitution did they do? Well, look right here, students. The measure of angle 1 equals the measure of angle 3. So they dropped the 3 and they put the measure of angle 1. So instead of 2 plus 3, they have 2 plus 1. And there we go. Okay, substitution property of equality. I hope that makes sense. Let's move on to the next one, number 38. Okay, now students, I want to show you something here. We're going to prove, and sorry students, I should not have done that. Hold on one second. I just don't want to lose this again, so I'm trying to save it while we go along. And the answer is yes. All right, now, students, if you'll take a look here at this theorem, Theorem 3.8, I want to show you something here. Here's how we learned these theorems right here. Do you see that? And notice, if we're going to prove Theorem 3.8, we can use anything before Theorem 3.8 if we want to, okay? We can use postulate 15, Theorem 3.6, 3.7. I don't think we're going to need these, but I want to remind you that whenever you're proving a theorem, you can use anything before it that you've learned, okay? So with that in mind, let's go ahead and prove this theorem. And let's see what we've got here, okay? This might not be working. It's kind of frozen up, it looks like. Let's see if it's letting us do anything. No, it's not. So we'll have to pause a second here. Okay, students, so here we go. First of all, we're going to brainstorm. We're going to draw the diagram first. Let's see if two parallel lines are cut by transversal. So here's my two parallel lines cut by transversal. We'll call this A, L, and M. Then we're going to prove that the alternate exterior angles are congruent. So we'll call this angle 1. And we'll call this angle 2. All right, next we write our given part. And of course our given is our if part. If two parallel lines are cut by transversal, so parallel lines, L is parallel to M, and A is a transversal. Okay, now we're going to prove the alternate exterior angles are congruent, so angle 1 is congruent to angle 2. Now students, this is so amazingly simple. If I put a number here like 3, it's so easy. Let's brainstorm. Could I not state that 1 is congruent to 3 because they're vertical angles? Definitely. And then could I not state that 3 is congruent to 2 because they're corresponding angles? Definitely. So I have 1's congruent to 3, 3's congruent to 2, so I can definitely state that 1's congruent to 2 by the transitive property. So it's really not that difficult. It's actually a pretty short proof, so I'm going to go really fast here, okay? So here's my statements. Here's my reasons. Number one, of course, is your given. So L is parallel to M. A is transversal. That's your given, okay? Now, step two, I'm going to state that angles 1 and 3 are vertical angles. I've got to state that first. I've got to state they're vertical, okay? And the reason is definition of vertical angles. Now, after I've stated that, I can definitely state that angle 1 is congruent to angle 3. Now, why can I state that? Because vertical angles are congruent. Now, next, I'm going to state that angles 3 and 2 are corresponding angles. And of course, the reason would be definition of corresponding angles, okay? And then I can state that angle 3 is congruent to angle 2, and the reason for that would be corresponding angles are congruent, okay? Now look what I've got in step 3. I'm going to change colors here. Look, I have 1's congruent to 3, and then I have 3's congruent to 2. So if 1's congruent to 3 and 3's congruent to 2, then I can definitely state that 1 is congruent to 2, and that's the transitive property. Remember, if something's congruent to something, and that same something here is congruent to something else, then I can say this is congruent to this. So if 1's congruent to 3 and 3's congruent to 2, then 1's congruent to 2, and we call that the transitive property. Okay, there it is, proof of 3.8. Now, we're going to prove theorem 3.9, okay? Pretty simple, actually, just like the other one. It's really simple. If a transversal is perpendicular to one of two parallel lines, so we know we have two parallel lines and a transversal, and it's perpendicular to one of the lines. So we're going to call this A, this L, this M. We're going to call this angle 1, and I guess we'll call this angle 2, okay? Now, we've got our diagram. We have two parallel lines cut by transversal so that the transversal is perpendicular to one of the lines. So my given is L is parallel to M, and A is perpendicular to L. Now what are we trying to prove? We're trying to prove that the transversal is perpendicular to the second line. That's your then part. So we're proving that A is perpendicular to M. Well, guys, there's not a lot of brainstorming to do. If I want to prove that two lines are perpendicular, all that I have to do is prove that they form a right angle, students. And look what I have here. I have a right angle right here. And so this is going to be pretty simple to do. I mean, angle 1 and angle 2 are corresponding angles, so I can easily state that 1's congruent to 2. And if 1's a right angle, then 2's a right angle. So this is not too difficult. Okay? All right, here we go. I'm going to put L is parallel to M, A is perpendicular to L, and that's your given. Now next, I'm going to state angle 1 is a right angle. How do I know that? Definition of perpendicular lines. Definition of perpendicular lines. Remember, if two lines are perpendicular, they form a right angle. So next, I'm going to state the measure of angle 1 equals 90 degrees. Well, that's easy. What's the reason? Well, definition of a right angle. Definition of right angle. Okay? Now, what can I say about angles 1 and 2? I can say angles 1 and 2 are corresponding angles, and that of course is going to be the definition of corresponding angles. And then I can state that they're congruent, so the measure of angle 1 equals the measure of angle 2. Excuse me, that's incorrect. I apologize. They're congruent. So I can state angle 1 is congruent to angle 2, and of course the reason would be these are corresponding angles. Alright, and then if they're congruent, then I know that I can definitely state, of course, that they're equal. I really hate to take time to do that, but it's the right thing to do. So the measure of angle 1 equals the measure of angle 2, and that's the definition of congruent angles. You say, Mr. Eric, why did you do that step? Because students, you can't substitute 90 in for angle 1 unless you have equal signs. You can only use substitution when you have equal signs. So now, if you'll look, I have an equal sign here. The measure of angle 1 equals 90. I have an equal sign here. The measure of angle 1 equals the measure of angle 2. So I can make a substitution. And for step 7, I can state that pick up your 90 and put it right here for the measure of angle 1. And so now I have 90 degrees equals the measure of angle 2. And of course the reason would be substitution. Substitution. And then I can state angle 2 is a right angle. And the reason is going to be definition of a right angle. Definition of a right angle. And now that I've finally stated that angle 2 is a right angle, finally I've stated that, then I can state that A is perpendicular to M, which is what I was trying to prove. And of course the reason would be definition of perpendicular lines, because if two lines intersect to form a right angle, then they're perpendicular. Okay, so there we go. So, I mean, it's long because it's a long proof because of all the nitpickiness you have to put in here, but it's not that hard to reason through. Okay? All right, moving on to the next problem, number 30. The directions say to solve for A and B. And so here we go. Let's take a look here. If you were to turn this around so that your parallel lines are running left to right like this, I think you'll be able to see that this angle here and this angle here are corresponding. So 100 degrees equals B minus 10. Alright? And so now we're going to add 10 to both sides. 110 equals B. Alright? Now, A is not too difficult. We have a linear pair. Here's a straight line with a line coming off of it, so they have to add up to 180. So if this is 100 degrees here, then A is obviously 80 degrees. All right. And the last problem, this is a doozy here, so really pay attention. I'll help you. Okay, watch this carefully, please, students. Okay. Now look, here's a parallel line right here. Here's a parallel line here, cut by a transversal right here. Got it? And I'm going to slide this out of the way. Okay, so there it is. Now look carefully. Parallel line, cut by a transversal. Parallel line, cut by a transversal. Okay, now watch this. Notice that this angle right here, that goes from the parallel line to the transversal. So this angle right here from the parallel line to the transversal is how much? 60 minus B, this angle right here. Now, look at this angle right here. Here's the parallel line, here's the transversal, this angle here. So here's the parallel line right here. And let's see, hold on one second here. I'm trying to see if I have the correct transversal. I might not. If I don't, I apologize, students. Let me see this real quick. Okay, I'm back, students. I apologize. Everybody makes mistakes. I really hate that, but it happens. So here we go very, very quickly. And let's see if we can't fix this. Okay, sorry about that. Okay, here we go. Here's your parallel line. Here's your parallel line. cut by a transversal right here. All right, now let me slide this out of the way. There we go. It's a lot better. Now take a look here, students. See how this parallel line here and this transversal form this angle here. So here's my parallel line, here's my transversal. This angle is 60 minus b. Now see how this bottom parallel line and this transversal form this angle here? Well, here it is. Here's the parallel line. It just helps to get rid of these extra lines we really don't need. This angle right here is 2b. Well, look, students, parallel lines cut by transversals. These two angles are called corresponding angles, so they're congruent. So you can say 60 minus b equals 2b. Now bring the negative b over and make it a positive b, and you're left with 60 equals 3b, and then divide both sides by 3, and 20 equals b. So there we go. b equals 20. All right, now let's do this again. Only now, let's use, and hold on one second. Okay, students, I'm back. Sorry about that. The computer program crashed again for some reason. So we had b equals, let's see here, b equals 20. All right, now see if we can solve for a here. A second ago we just dealt with this parallel line here and this parallel line. So now let's look at the other parallel lines. Right here we have this line here and this line here, and they're parallel. Okay, students, and I have a transversal right here like this. Now let's slide this out of the way. Let's see what we can learn here. Take a look at this. It's really cool. Okay, this angle right here is this angle right here. It's 4a minus 90. Okay, and see a right here is this angle right here. Well, that's this angle here. So this angle here is a. So I have, look, students, I have two parallel lines cut by a transversal. This angle and this angle are corresponding angles, and corresponding angles are congruent. So I have 4a minus 90 equals a. Okay, so I'm going to bring the 4a over and make it a negative 4a, so it's gone. So I'm left with negative 90 equals 1a minus 4a is negative 3a. Now divide both sides by negative 3. Divide by negative 3, divide by negative 3. And negative divided by a negative is a positive. 90 divided by 3 is 30. So 30 equals a. So there we go. Okay, so not too difficult, okay? I hope this homework video has been a help to you. If you have any questions, don't hesitate to call or email.